So I went through the test and looked at did a little statistical analysis of all the problems on the test and which ones were the people in our class as a whole did the best and the worst on. And I'm going to work in reverse order here. I'm going to start with the ones that people had the hardest time with and just kind of work in the opposite direction. Okay. So not surprisingly, this one was one that people had a little bit of a tough time. I'm going to do two of these. Maybe. We'll see if we need to do two. But we want to go through this whole process. And I could see from the work that, for the most part, people were pretty good on this, but there were a few, in certain places, like checking the solutions, there were a few issues. So what do we do here? If we're solving an absolute value equation where there are variables outside of the absolute value, right, we're going to solve this just like we would a regular absolute value equation, same rules, but we're going to have to check for extraneous solutions, right? And you think about why that might be. There's possible I could get some values of x that would cause this side of the equation to be negative, which wouldn't make sense for the output of an absolute value, right? Everybody see that? So that's our rule. Anytime there's a variable outside of the absolute value, when all the dust settles and we find our solutions, we always have to check them. So what are our steps then? First step is isolate the absolute value, and that one's already done, isn't it? The absolute value is already by itself. Step two, we want to set up our two cases. Okay, so we need to do that. How's that work? How do I set up my two cases? What's the pattern I follow here? I got to set up my two cases here, set up the two equations from this. Okay, so what's positive? So what do you mean by that? What's equal to what? Okay, so what do I do with the x minus 2, what's inside the absolute value? Say it again. Well, I'm gonna leave it the same. It doesn't change, right? So whatever's inside the argument of the absolute value, case 1 is going to be that equals something, and case 2 is going to be that equals something. Okay, if what's outside is 4x plus 4, what are my two options? There you go. Follows our traditional rules, right? We're going to set up two cases where whatever's inside the absolute values is equal to the positive of what's outside, or it's equal to the negative of what's outside, the opposite of what's outside. And then step 3 is solve. I just solve and get solutions. Okay, so if I solve these two, what's going to happen here? So if I solve these, I'm going to subtract x to this side, right? And I'm just going to give me a 3x on this side. I'll subtract the 4 over there. Get that, agreed? Divide by 3. So there's one possible solution. I'll have to check it, but there's one possible solution. Over here, I'm going to distribute the negative, and I'll push the 4x's over here, right, and get a 5x. I'll add 2 to both sides and get negative 2. We good? Okay. Divide by 5, and I get x equals negative 2/5, right? So there's step 3. I solve. Now, this is important. I have to include, this is not optional, step 4. I must check my solutions, right? Got to check them. So I've got to plug them back into the original absolute value equation. Okay, and I left Desmos available because we're dealing with fractions here on a test, just to kind of make this a little quicker. So let's review. Let's do this with Desmos. So if I do this process with Desmos. And all I have is the Desmos scientific, right? That's enough. So I'm going to set f of x equal to the left side over here of my absolute value equation. I define f of x as the absolute value, and I have to include the absolute value. Some people didn't include the absolute value. Have to include the absolute value. Right side is equal to 4x plus 4 in my original equation. And then I'm just going to check both these solutions. Okay, so let's try my solution negative 2. Is it going to work? Is negative 2 going to be a true solution or an extraneous solution? I don't even have to plug it in. You can probably tell me. Look at the original equation. It's going to be false, isn't it? How come? Ah. Everybody see that? When we plug it into the right side, I'm going to get a negative number. Can that happen? I can't have an absolute value of something equaling a negative, right? So I already know that's not going to work. We can show that it doesn't work. F of negative 2 gives me positive 4. G of negative 2 gives me negative 4, right? So that one doesn't work. That one we have to cross off. Okay. Is the other one guaranteed to work? No, it may not. It's possible they're both extraneous, so we got to check it. So I'll just change that into a negative 2/5. I get 2.4, make it a fraction. G of negative 2/5 gives me the same thing, right? So when I plug that into my original absolute value equation, I get 12/5 on both sides of the equation. So that is, take a little picture. Oops, what happened there? Oh, there we go. Okay. So that's what I want to do. There we go. Okay, so that one's good, right? That's my solution. Questions? Does that work? Okay. Maybe I'll just do, I don't probably need to do another one, right? But this was a case where only one of the solutions worked. You could have had problems where both worked or none worked. But you got to check the solutions to find out. Okay, so what about one like this? This was another one that was a very commonly missed one. Okay. So what do I do here to solve an absolute value inequality? Isolate. First step is always isolate the absolute value, right? So let's go through all these steps. I'm going to isolate the absolute value. That just amounts to dividing both sides by negative 5. Okay, that's good. That cancels the negative 5s, and so I get my absolute value isolated. On this side, I get negative 15 divided by negative 5 is 3. What do I have to be careful about here, though? Got to flip the sign, don't I? Divided by a negative, so that's going to get flipped around. And I get my isolated absolute value of x minus 6 is less than or equal to 3. So now what? What's the next part of the process? Good, I'm going to set up the two cases. And in the case of an inequality, I'm going to set up a compound inequality. The two cases combine into a compound inequality, right? So how does this one set up? If the isolated absolute value is less than or equal to a number, what kind of an inequality do we get? This is the other part where some people just, they went astray on this step. They picked potentially the wrong kind of pattern. Which one is it? And or? It's and, isn't it? Yeah. Pull down my little template here. There it is. Okay, there's my pattern, right? That's the inequality pattern we're going to use. So whatever's inside, I wonder if I can make those. I can't. So whatever's inside is going to end up being in the middle, right? It's an and inequality. So in this case, in the middle I get my x minus 6. It's going to be greater than the negative number and less than the positive number. So I'm going to get a negative 3 on that side and a 3 on that side. And because we're doing a less than here, this becomes that. Okay, give me 1 to 5. Is that good? All good with that? Okay. Then I just solve, right? So next step is solve. And I don't have any variables outside, so I don't have to check my solutions or anything. And checking is optional. Just I can check to see if I did the math right to verify my solution, but there's never going to be extraneous solutions here because there's no variables outside of the absolute value. So to solve, all I have to do in this case is just add 6 to everything, right? I get my x in the middle. I get a 3 and a 9. Okay? Questions? That make sense? Okay. So let's look at one like this, same kind of thing. This time if I divide, would you everybody agree here if I divide by -8? It's going to flip the inequality, right? So that's going to become a greater than. Inside I'm going to have my 2 minus x. And outside I'm going to get a positive 4. Like that. So what's the pattern there? If my isolated absolute value is greater than a number, is it an and or an or? That's an or. Yep. Okay, so let me grab that pattern. All right, so there's my pattern. So by that pattern, whatever's inside 2 minus x is going to be greater than the positive, or whatever's inside is going to be less than, and here's another mistake. Sometimes people wanted to make both of those greater thans, right? It's greater than the positive or it's less than the negative. And now I just solve, right? Okay, so to solve, I could do this a couple ways. I could push the x over to this side. That's what we did last time. This time, let's just leave the x where it is. Subtract 2 from both sides and get negative x is greater than 2. Multiply or divide both sides by -1 and it just flips the inequality, right? So I end up getting x is less than -2. Or, how about over here? I'm going to subtract 2 and get negative x is less than -6. So I'm going to flip the inequality and get x is greater than 6. There's my solution. X is less than -2 or x is greater than 6. Okay? Give me 1 to 5. How are we doing? Okay? All right. Okay. Here's another one that was a little bit problematic. If we use the word and, right? So if I use the word and, I'm going to have to, this is not starting off as a compound inequality. I'm just solving each of these separately, and I'll combine my answers into a compound inequality. So we're going to split this thing in two. Over here, all I've got to do is divide by 9. So I'm just going to end up with a solution x is less than or equal to -3, and if I divide by 5, x is greater than or equal to 6. Okay, so how would I say that using a compound inequality where x goes in the middle? There you go. So I got my x in the middle. If x is, let's look at this solution. If x is greater than or equal to -6, oh, okay, hang on a second. So, does that even make sense? Let's look at graphs of these, right? It's going to, if I try to write this directly, I'm going to get something really weird. I'm going to get the x in the middle. It's going to be greater than or equal to 6 and less than or equal to -3. Does that look weird? What immediately strikes you as being wrong about that? Yeah, I don't have a lower limit here and an upper limit there, right? So right away, we know there's something weird about this. So if I graph these two, the graph of the blue part of the inequality looks like that. The graph of the red part looks like that. And for an AND statement to be true, how many of those solutions have to be true at the same time? Both, right? If I asked you if you have a dog and a cat, you could only raise your hand if both of those statements were true. I have a dog and I have a cat, right? So that's got to be an intersection. And there is no intersection. There's no place where that is both red and blue. So what's the answer to this one? No solution. Okay? Okay, give me 1 to 5 on that one. That's a little trickier. Okay, I think the graph is very helpful on that, right? When we solve this and. Now, what if this had said x is greater than or equal to -3 and x is less than or equal to 6? Well, then it would have been easy. It would have worked easily as a compound inequality, right? But when I get something weird like this and I look at the graphs, there's no place where they're overlapping. If it's an and statement, if they don't overlap, there is no solution, right? Okay. Same kind of thing here. Let's look at this one. So we got two parts of this. 4x is less than or equal to 24. Divide by 4. I get x is less than or equal to 6. Or, if I divide by 7, x is greater than or equal to -5. Okay? Well, let's graph this. So if I graph x is less than or equal to 6, it looks like that. If I graph x is greater than or equal to -5, it looks like that. For an OR statement to be true, how many of the solutions have to be true? Only one at a time, right? So what's the interval where at least one solution is graphed? All of it. Yeah, it's everything, isn't it? Right? The entire real line is either red or blue, or both. It doesn't matter if it's both, but as long as at least one of those is graphed, then that's a solution, right? So this one would be all reals. Okay. Oh, okay, what about this one? Yeah, I know why I put this one up there. What's the answer to this one? Right, those, right, when you get a negative on the opposite side of an absolute value, that's where you got to really pay attention, right? So here's my question. We've got the output we've got an absolute value output. We want to know when is that greater than or equal to a negative number. If it had been an equation, the answer would have been no solution, right? Because the output can never equal a negative number. But that's not what's being asked. What's being asked is, when is the output of the absolute value greater than or equal to a negative number? How often is that true? Always, isn't it? Agreed? Isn't the output of an absolute value always non-negative, 0 or positive, right? So if the output's always 0 or positive, 0 or positive numbers are always greater than negative numbers. Agreed? So that's a tricky one, but doesn't matter what you plug in, it's always going to work, isn't it? Okay? Okay, these. If we're solving for S, okay, let's walk through these steps here. Okay. So we're trying to isolate S, right? So we're using inverse operations, okay? Do I need to add or subtract anything to both sides? Thumbs up, thumbs down. We take a vote on that. You can be real subtle about it. I wanted to see where we stand on this. What do you think? Seeing lots of thumbs down. That's good. How come? Trey, how come? There you go. Because it's in parentheses, isn't it? The plus is in parentheses, so I don't get there till the end. Good. Okay, so what's the first thing I got to do then? I don't want to distribute. I could, but it makes it much harder. Right? And let me remind you again why that is. If we're isolating a variable, we shouldn't have to do any steps in the simplifying direction. If I can point to a single variable, I can isolate it. I don't have to do anything normal, top to bottom simplifying stuff. Every step I take should be moving things away from the S. Suggestion? Do you have an idea? Multiply by 2. Yeah, we're good. We have to undo multiplying by 1/2. So our first step would be to multiply each side by 2, and that cancels the 1/2, right? So there's one step. So that gives us 2b equals f times the quantity S plus k. Now what? Divide by f. Step 2. Divide by f. So I cancel those guys. Now I've got 2b over f equals S plus k. What's the last step to get the S by itself? Subtract k. There we go. So that's in parentheses step, right? I don't really need the parentheses anymore, but they're there. Right? I can get rid of them now, though, because nothing's being distributed. Last step, subtract k. And those guys cancel, and I get my answer. I get S by itself equals 2b over f minus k. If people miss this, usually what they did is they tried to subtract first and then divide. But that's not what we do, right? We don't get to the subtraction until the very end. Okay? Okay, here's another one I want to go through. This is clearing fractions, but it's maybe a little bit tougher because I've got what people tended to miss on this. was not distributing that negative to both parts. Okay, what's the common denominator I'm going to multiply through by here? We're going to have to look at multiples of what number? 7. Okay, so 7, 14's not going to work, 21's not going to work. What's going to be the first multiple of 7 that's going to work for all these? Well, that's going to be a big one, huh? $105. Yeah, that's going to be it. That's going to be the first one that works. So I've got to distribute through a 105. Okay, so let's look at this though. Now, what we can do from here. So rather than distribute this 105 and get all these enormous numbers, we're going to reduce first and then distribute, right? We're going to use that little trick. So if I reduce first, 105 over 5 is what? 21. So I'm going to reduce the 105 over 5 to a 21 and distribute, right? Okay, what's 105 over 7? Not that big. Yeah, 15. Yeah, 15. Yep. Okay, so cancel that. Now I'm going to distribute a 15. 105 over 3. There you go, 35. And I'll distribute that. Okay, but what's that look like? What's that look like when I do this distribution? So I've got 21 times 3x minus 15 times the quantity x minus 5, right, equals 35 times the quantity x plus 3. Does that make sense? Okay? And so usually this was a pretty small mistake. Usually the mistake was that negative didn't get distributed, right? So if I multiply here, I'm getting 63x. If I distribute the negative 15, I get negative 15x plus 75, right? That's the part that people tended to miss. And over here, I get 35x plus 105 if I distribute the 35, right? And from there on out, it's a piece of cake. Okay? Make sense? Okay? You want to see this one or not? I don't care. Now we're getting down to the ones where maybe I'm just wasting your time on these. I'll tell you what, from this point forward, this is just carefully distributing. What people tended to do wrong on this was they didn't distribute the negative to that one again, right? If I distribute the negative, that makes that a positive, right? And then when I distribute the negative 3 over all that stuff, I got to be careful about the signs again, okay? Again, those, you just kind of got to practice those, right? Just the properties. I think we're probably done. I think I hit the big ones. Okay, any questions? All right, so we don't have enough time for me probably to cover stuff. I'll let you wrap up tests. You can finish up an assignment. Tomorrow we'll start on new stuff in here. Okay, when are we out of here? 45, yeah, I probably don't have enough to really. Yeah, probably not. Mm-hmm.
So for the and and or, right?
Mm-hmm.
So if it's facing each other like that, it's an or.
Well, okay. If you get an isolated absolute value that's greater than a number, then it's an or. If the isolated absolute value is less than a number, then it's an and.
Oh, so it's if the question is flipped like that. So like that, it's an or. So if it's facing.
Yes,
okay.
right.
As where. Okay, this one was what? Okay.
Yeah, does that make sense?
Yeah.
Yep. Okay.